So in this video, we will solve two problems. The very first problem relates to uh, the force experienced, the normal force experienced by a block of wood that is sitting on the floor of a elevator car. So this elevator car is being pulled up, and from the first elevator car, we have a second elevator car that's suspended. Okay, and the tension in the rope that links these two cars is given. So the masses of these elevator cars are given and the mass of the box is given. So we want to know what is the normal force that is experienced by this block that's sitting on the floor of the elevator. So let's get to it. So, so here the tension of 19,100 newtons, okay, minus the weight of the bottom elevator car, okay, equals the mass of the bottom elevator car times the acceleration. So the acceleration here is 191,000 minus 1300 times 9.8 divided by 1300, and that equals 4.89 meter per second square. So what we know here is that this entire system is moving together. So the acceleration of this elevator equal to the acceleration of this elevator, and that's equal to the acceleration of the block of wood that's sitting in there. So here, if we draw a free body diagram, okay, for the block of wood, we see here that the normal force, okay, minus the weight, it is the net force acting on the block of wood, equals its mass times acceleration. So here the normal force equals mass times A plus G, and the mass here is nothing but 12 kilograms, okay, times acceleration is 4.89 plus 9.8, and this is roughly 176.3 newtons. Okay, so that's what it comes out to. So let's look at another problem. So here, so we are pulling a block of wood, okay, that's with a string attached to it, and the angle that the string makes with the horizontal is 25 degrees. So we want to find the acceleration of the wooden block. Okay, the mass is given. The mass here, m here, equals 5 kilograms. So the acceleration here is nothing but F times cosine theta divided by m. Okay, because essentially the component of the force in the horizontal direction is F cosine theta. Okay, so if an F here is given to be 12 newtons times cosine of 25 degrees divided by the mass equal to 5 kilograms, and that comes out to equal 2.175 meter per second squared. Okay, so now the question being asked here is that if we pull hard enough, okay, what is the acceleration of the block at which the block just lifts up from the floor? Okay, so when the block just lifts up from the floor, F sine theta equals mg, right? So here, so F here equals m times g divided by sine theta, and that is 5 times 9.8 divided by sine of 25 degrees. Right? It is 115.9 newtons. So the acceleration here is the same as what we see earlier, is F times cosine theta divided by m equals 115.9 times cosine of 25 degrees divided by 5, and that equals 21 meters per second square. So I hope this gives you a flavor for the problems that we are solving, uh, as to how to determine the accelerations by finding the correct components of the forces. Okay.